Well, hello and welcome back again. Today's chapter is the Ethernet. Ethernet is a well-known and documented technology. As a matter of fact, few would know that Ethernet has been for years the most common used LAN, local area network technology. It defines how computers talk to each other in a local area network. So what we'll cover quickly, we'll go over the operation of Ethernet. How does it work? What layer of the OSI model, what are sub layers. You will find out that Ethernet is one of the only layer in the TCP/IP that has two extra layers. We'll talk about the role of MAC addresses. Then we'll talk about switches, how switch function, and we'll compare them to routers. And finally, we'll go all the way down and talk about address resolution protocol, which is ARP. How does it work? And how is its importance, and we also talk to it, if you want, from a network and security perspective. All right, so the Ethernet, as I said earlier, is one of the most widely used LAN technologies, and it's defined in IEEE 82.2 and 82.3 standards. One of the many things that you should know earlier about the Ethernet, see how it defines the network, the network speed, and also define the type of cable, and it defines when you physically connect in computers how you connect, in other words, what type of cable, what type of network, and so forth. If you look at the OSI model, or starting from duplication, you can see that the Ethernet works at two layers. It works at the data link layer and it works at the physical layer. And you'll see that data link layer is made of two layers. That is the LLC and the MAC address. So here is the Ethernet, and please remember that Ethernet works at two layers, a data link layer and also on physical and the physical layers. All right, the Ethernet encapsulations. The Ethernet LLC or sublayers handles the communication between the upper layers and the lower layers. So you can see we call this upper layers and we call down the lower layers if you want to. The MAC sublayers, if you can see, this is the LLC. So LLC basically divide upper and down. Now, what is the role of the MAC address? The MAC address sublayer added a MAC addresses to the frame, if you want to add MAC addresses. And once it adds MAC addresses, it takes the frame and pass it down to the physical layer, of the network interfaces. Looking at a frame, an Ethernet frame, you can clearly see here that in the Ethernet frame, the MAC sublayer, like I said before, has two primary responsibilities. They're right here. One is encapsulation, and we talked about encapsulation in network layer, and the other one is a media access control. What happened at the encapsulation process? You can see here, encapsulation is in charge of framing and addresses and error detections. All right. The media access control, on the other end, is responsible for placement of frames on the media. And the media mean on the cable, and take them off the cable. So in other words, the Ethernet is in charge of taking frames from the computer, putting down on the cable, and also taking frames from the cable, or really the electrical pulses from the cable, and pass it over to the rest of the OSI model or networking layers. If you compare MAC addresses to TCP/IP, if you compare MAC addresses to IP address, one of the first things that you will notice that MAC addresses, unlike IP addresses, are depicted in hexadecimal. If you remember, especially IP address, IPv4, it's in decimal number. An example of IP address may be 192.168.1.1. But MAC addresses, IP addresses are 32-bit, MAC addresses are 48-bit, are expressed in hexadecimal, 4 bits hexadecimal digits, right? MAC addresses representation. If you want to see what kind of MAC addresses or physical address you have. By the way, MAC addresses is also known as the physical. If you go to any Windows machine and you type ipconfig/all, you will see the MAC and the physical address. And I'll do this as a demo. And in Linux or Mac environment or Unix environment, you type ifconfig. Another really command in also Windows, which a few people know about, is known as get MAC. If you go in Windows, you go and type get MAC, it will display the MAC addresses. And by the way, here is a MAC addresses that you can see right there. It's in hexadecimal, and every single bit, if you want, is really 4 bits. It's made of nibble, 4, 8, 12, and you keep counting until you get 48. So here are example. Here's another example. So here is a dash, and here is what we call it, and here is a colon, and here's a period. The most common one that I really know are either the dashes or, and where is the difference? It usually depends what operating system you really are using. All right, now let's talk about, if you want, let's talk about LAN switching. A switch works at one of the most common devices in local area network, and Ethernet work. If you can say Ethernet, like switches, is a layer 2. So switches are a layer 2 Ethernet. And what's the job? What's the function of a switch? A switch physically allows multiple devices in a network to communicate with each other. And how does it do that? It does that by using MAC addresses. So you can see here that a switch, this is an example of a switch. Switch can have 8, 16, 24, or even 48 port, right? Port, this is known as a port right here. And the way switch kind of forward traffic from one station to another station is by learning every single station MAC addresses, everything. A switch stores all devices connected to it MAC addresses in something known as the CAM table. CAM table. Remember that term, CAM table. So the switch has a table that looks like this, where you say in port 1, I have MAC address 008. This is just an abbreviation to make it short. In port 2, I have 00OB and so forth. This way, when the traffic, let's pretend from computer D needs to go to computer A, the switch make that decision by using the sender, the source MAC addresses, and the destination MAC address. All right. Learning MAC addresses. How does a switch learn MAC addresses? It's very simple. A switch learns MAC addresses by really listening what is happening on a network. Every time a device asks a switch about, hey, can you find this computer for me? The switch asks, what MAC addresses you're looking for? And the guy says, I'm looking for A000. The switch will find. It find what he called. And it said, switch examine all incoming frame for new source MAC. And if he does not know about it, if it's not in his table, he will automatically add it. All right, he will automatically add it. And you can see right here, the switch has destination, knows about the destination MAC addresses and MAC addresses, and also the source MAC addresses. And he said, by default, most Ethernet switches keep an entry table for 5 minutes. After 5 minutes, if a switch does not hear about a machine, he will delete its cache. All right, learn the MAC addresses. The process to forward the destination MAC address is very simple. The destination MAC addresses is a broadcast, can be learned by using a broadcast. Maybe a PC sends a MAC broadcast, and once the switch hear that broadcast, hey, I see that PC4, PCD connected to port 4 with a MAC address as 00D. He just sent a broadcast to everyone. Now I'm going to add his MAC addresses to my table. This goes as a broadcast. A switch can also learn another computer's MAC addresses by when one PC sends what we call a unicast packet to another PC. So he will learn that and add it to its table too. Right now, when a switch is need to forward a packet or frame from one port to another port, how does he do that? There are two common methods. One is known as store and forward, and the second method is known as cut through. The difference between it is really simple. What happens in store and forward? What happens is that the switch receives the switch receives the entire frame from one PC or one port before he forwards it to another PC on another port. He waits for the entire frame. That is known store and forward. He keeps storing. When he has the entire frame, and only then he sends it. That's good. Cut through, however, it's different. The switch does not wait for the entire frame. As a matter of fact, as soon as it received at least 64 bytes of of the frame, it sends it. So that is a difference between store and forward and cut through. So what are this? There's two techniques used by switches to forward frame from one port to another port, or from one destination to another destinations. How do we connect switches to other devices, such as switches or as routers or as a PC? Well, to understand this, we'll compare the old switches and the new switches. In the old days, whenever you need to connect a switch to another switch, you really need to use a crossover cable. In the same case, if you need to connect a switch, if you need to connect a switch to the router, you don't need crossover cable. But anytime you're connecting alike devices, like switch to switch, router to router, PC to PC, you need to use a crossover cable. Now, modern switches has something in them. It is known as MIDIX. What MIDIX or MIDIX is, that the switches, the two switches connected or two devices connected, they'll sense what device in the other end they're connected to. And in this sense, they're connected to another like device as a switch or a router. What they're going to do, they will automatically cross over the cable. So you don't have to make crossover cable anymore. The switch cross over the cable automatically. All right. One of the most common thing that modern switches use, and not just switches, really that we use in communication today, is really known as Address Resolution Protocol, or ARP. ARP is a very important in today's communications, and I'll show you attackers, hackers, they do know how ARP works, and they use it to kind of hack machines and stage attacks on computers. All right, so you can see over here, we have a source PC with an IP address and of course a MAC address, and he needs to communicate with what we call a server. So the first thing, I hope you understand this, the first thing that PCA know about this server, he knows its name. He knows the name. Now, once this PC knows the name of this server, what he's going to send, he knows the name. He's going to say he needs to use some kind of protocol to get the IP address of the destination, and that usually a DNS. This machine will query its DNS and try to learn about this machine IP addresses. By now, this PC knows the destination IP addresses, and he knows the destination MAC addresses. I'm sorry, name. So the next thing after name and IP, this PC need to know this PC's MAC address. How does he do that? He does that by sending an ARP. ARP is an address resolution protocol that resolves an IP to MAC addresses. Once the computer knows the destination MAC addresses and his own MAC addresses, and he knows his own IP addresses and the destination IP address, only then he forward that query to what we call to the server. It's really important here. It's just tricky, and there's a lot of questions in Cisco tests about this analogy right here. When the question is, well, what happened if the computer, in this case that you see over here in the previous slide, both the computer, the client, and the server are in the same network? But what would happen if the computer is in one network, as you can see here, 192.168.1, and the server is in completely different networks, and there's a router between them. So broadcasting and sending ARP, it is not going to work because by default, a router block all ARP. So what's going to happen? PCA, he's going to go process known as ending. The ending process is a mathematical procedure. And once he does go to process ending, he will figure out, and basically what is ending? He takes his IP address and end it with his subnet mask and look at the result. Then think that the destination IP addresses and his subnet mask and end it with his subnet mask, and then he compares the result. If the result is the same, this PC will know that the computer he needs to talk to is local. But if the result is different, he knows that this computer is remote, and he needs to do what? He needs to forward that to the nearest router to it. In this case, the closest router is this one. So this PC will send an ARP asking this router for its MAC addresses. So you need to know that MAC addresses does not stay all the way. MAC addresses change based on the router, that it hits. So this request that is going to this PC at this point, this computer MAC addresses, this router will replace the MAC addresses with its own MAC address, but it's going to keep its own IP address. And this frame is sent to the next router. This next router will replace this MAC address's IP address and put its own MAC addresses, but always keep the source IP addresses, then forward that query. And what's coming back, it does revert. It's very important to remember this process. All right, so ARP, it said when a device sends an Ethernet frame, it contains these two addresses. It's the destination MAC address and the source MAC addresses. To determine the destination MAC address, the device uses ARP. Hey, PCA or computer 192.168, I have your IP address and I don't know your MAC address. Can you please send me your MAC address? Now, if the switch knows the MAC addresses, there's a good chance that switch will reply. Say, I know that PC MAC addresses that you're looking for. I have it in my table. ARP, as you can see, provide two basic functions. One is resolve IP map to address, and the second one, it maintains the table of mapping. As the switch has a table called as CAM, C-A-M, in where he knows every single port and what PC is connected to it, and what MAC addresses is it really using. All right, we'll talk about ARP. We can remove ARP. As a matter of fact, the switch removes the ARP by itself after every 10 minutes. In Windows, you can go manually and do ARP-D, and it deleted all the ARPs. If you need to see the ARP table, and I did this one before, in Windows you type ARP-A, all right, and in the switches, Cisco switches, you're going to type show IP space ARP, and this is the command I'll do, and it shows us. This is the lab that we're going to do together. ARP broadcasting, when a PC needs a remote PC, it's possible to send a broadcast ARP, broadcast to every single, every single device in the network. That's called a broadcast ARP. One of the most common attacks on ARP is called ARP spoofing. When this PC right here, this hacker right here, he's going to wait for this PC, going back, he's going to wait for this PC to query, to ask, hey, router 1, I need your MAC addresses. And before this router returns its MAC addresses, this PC, this hacker's PC, will reply with its own MAC addresses. And this is known as ARP spoofing. And it's an example of ARP attack. So we'll quickly talk about, we explained the difference between an IP and MAC addresses. We said that an IP is logical, an IP and MAC address is physical, and we explained Ethernet, and we said it's the most common use LAN technology out there, and we said that it works at 2 layers of the OSI model, and I also said that switches use CAM table, in where they learn about every single device connected to them and what what's their MAC addresses, and that's how switches, unlike routers, use MAC addresses to forward frame from one port to another port. So we're done with the chapter. Next part, we're going to move on to the lab.